Good afternoon and welcome to Callum Cymru revision sessions. This session will focus on the higher tier maths GCSE and will be presented by Mrs. Alexa Jones from Gowerton School. The session will last around 45 minutes where Mrs. Jones will go through the relevant subject content. If you have any questions, please use the question and answer section and I will endeavour to answer your questions during the session. The session will be recorded with the recording and any relevant resources uploaded to the e-sgol website in the Callum Cymru area.
Thank you, Mr. Walters. Okay, so today we're going to have a look at similar shapes and I've got a little warm up for you. So I've got two triangles here. Can you please find the missing angles in each of these triangles? And I'm just going to give you a very short amount of time to do that. Okay, I'm going to have a look at those now. If you didn't have enough time, then please pause the presentation and start it again when you're ready. So the angles in a triangle add up to 180. So I'm going to start by adding up the angles that I can see. So I've got 125. So I have 125 already. And then 180 subtract 125 gives me angle of 55 degrees. So my A value is 55 degrees. And for B, I add up the angles that I've got, 155, so that's 155, 180 subtract 155, that is 25 degrees. So you can see that actually B is 25 degrees. And what we actually have here is we have two triangles where the angles are exactly the same. Now in a triangle, if the angles are exactly the same, it means they are similar. They might not be exactly the same size. One might be an enlargement of the other, but because the angles are the same, they are similar triangles. So triangles are similar if the angles are the same or if the corresponding sides are in the same ratio. And we're going to have a look at that now. This example says, show that these triangles are similar. And I've got one triangle with sides 4, 5, 6, and the other one with 6, 7.5 and 9. The first thing I have to do is I have to work out which sides correspond, so which sides match. So looking at this, I can see that 4 is the shortest side here, and 6 is the shortest side here. So these two correspond. And I need to work out what the enlargement scale factor is. Now with that, you might look at that and say, oh, well, I can see that that is multiplied by 1.5. So this is an enlargement of 1.5. If you can't see the scale factor, and sometimes the numbers are quite difficult, the way that you can find it is you can divide one number by the other. So if I divide 6 by 4, that gives me 1.5. And actually the same is true for the other angles, the other sides on here. So if I take 5 and I multiply it by 1.5, I get 7.5. And if I take 6 and I multiply it by 1.5, then I get 9. So all I would have to do is I would have to show for each of these that you can multiply by 1.5 and you arrive at the corresponding side on the other triangle. So let's have a look at a question where we've got to explain why triangles are not similar. So on this one, it's not quite so easy to see what the scale factor would be if they were similar. And it does say explain why they're not similar. So I am expecting the scale factor to be different here. So the way that I do this is I divide the corresponding sides. Looking at them, the longest side on this one is 8 and the longest side on the larger one is 9.6. So this side 8, I'm going to look at what the scale factor would be here if these were similar triangles. and I'm going to divide 9.6 by 8, and 9.6 divided by 8 is 1.2. So if I multiply 8 by 1.2, I get to 9.6, which is the length on this triangle. Now, the next one I'm going to look at is the middle side. So this 6 is the middle of the three sizes on this triangle. And on this triangle, the middle of the three sides is 7.2. So I'm going to see what the scale factor is here. So for this one, I'm going to do 7.2 divided by 6. And 7.2 divided by 6 is 1.2. So this one is also multiply by 1.2. Now I'm going to look at the last one, the shorter side on each triangle. So let's look at this one. And if I do 5.6 divided by 4, 5.6 divided by 4, this is 1.4. So this one is multiplied by 1.4. And what I'm going to say now is I just need to explain what I've done, because it does say here, explain. And I'm going to say the triangles are not similar. So the triangles are not similar as the sides are not in the same ratio. The triangles are not similar as the sides are not in the same ratio. Now, the important thing here is I needed to do both parts of that. I needed to explain, so I did need to put a sentence in saying why they are not similar triangles, but I also needed to do the calculations. So if I'd just looked at this and done this in my head and then written the explanation, that wouldn't be enough either, because I do need to back up what I'm saying with some calculations. Okay, let's have a look at this one. So this says these two triangles are similar. Calculate the lengths x and y. Well, the first thing I have to do is I need to work out which sides match. And looking at this, I can see that my 8 here, I've got this angle marked here, and then I've got this angle marked with the double line on this side. And on this other triangle, I can see this is my single line, and then I've got the double line here. So the 8 corresponds with this 10.4. And what I need to do now is I need to work out what the scale factor is. So I am going to divide 10.4 by 8 to work out what the scale factor is. And if I do 10.4 divided by 8, and you'll notice I'm checking my work on a calculator here because I'm thinking to myself, I think it's 1.3, but if it's a calculator paper, it's always worth checking on a calculator, because quite often you'll see that people know exactly what they're doing, but they've made a little slip with a basic calculation which has lost a mark. So when I divide that, I get 1.3. So I know that this triangle, it's an enlargement with a scale factor of 1.3 of the smaller one. Now, if I am to look at side X first of all, well, this side 5 matches with the X here, and that's because this has 1 marked here and nothing marked here, and X has 1 marked at the bottom and nothing marked at the top. So you've got to make sure you're matching the right sides together. So because I've been told they're similar, I know that X is 5 multiplied by 1.3. So in order to find X, I do 5 multiply by 1.3. And 5 multiplied by 1.3 is going to be 6.5. So I know that X now is 6.5 centimetres. Now, the last side that I've got is 5.2, and I've got to use that to find Y. When I'm going from the larger triangle to the smaller triangle, instead of multiplying by 1.3, I divide by 1.3. So if I divide 5.2 by 1.3, I will find the length Y. So my Y value is 5.2 divided by 1.3, and 5.2 divided by 1.3 is 4. So that one is 4 centimetres. And actually, there's another thing that you can look at on this. If you look at, let me just pick a highlighter up. If you look at 10 here, can you see 5.2 is half of 10? Well, here I've got 8 and y is half of 8. It's 4. That's what we just worked out. So actually, you can look at these. You can always do a double check by looking to see if the sides on the triangles are in the same ratio as each other. So the ones on the small triangle are in the same ratio to each other as the ones on the larger triangle. Okay, so I've got a question here. So I'm going to give you a minute to think about this one and see if you can work out the missing lengths. The one thing that I would say with this is you need to be very careful to match up the right sides. So you need to work out which sides match up on these triangles. And I would often redraw the triangles. I would often redraw them in the same orientation so that it's easier to see what matches, what is corresponding. So I'm going to give you a minute and then we'll go through the answer to this one. Okay, let's have a look at this. So again, if you haven't had enough time, please pause the presentation. So the first thing I'm going to do is I'm going to take this triangle up here and I'm going to turn it around so that it's in the same orientation as the bottom one. And this lower triangle, it has 1 angle marked on this side and 2 on this side. So I'm going to draw the other triangle in the same orientation. So I'm just going to draw a rough sketch. I want 1 to be marked here and I want 2 to be marked here. So looking at this triangle, the Y now I can see would be at the bottom here. And then 12, that is on the side with the 2 angles marked. So this one would be 12 and 15 is on the side with 1 angle marked. So I'm now looking between these triangles and I can see that they're now in the same orientation. So I'm looking for the sides that correspond, the sides that match, and I can now see that it's 8 with 12. So I'm going to find the scale factor here. And again, you might be able to look at that and see straight away that it's 1.5, but if not, then 12 divided by 8 is 1.5. So I now know that this is the larger triangle and I'm multiplying by 1.5. If I'm multiplying this one by 1.5, then to find y here, I have to do 18 multiplied by 1.5. So my y value is 18 multiplied by 1.5. So my y value is going to be 27 centimetres. And then on this one, I'm going from the larger to the smaller. So on this one, I'm going to divide by 1.5 to go from the larger to the smaller. So to find x, I do 15 divided by 1.5. And that gives me x as being 10 centimetres. Right, let's look at the next one. Okay, so with this one, have a little think about this one and think, what is going on here? This is actually a similar triangles question, but it is a little bit harder to see than the ones that we've already seen. So I'm going to just give you a few seconds to have a think about that. Okay, so what I'm going to do is I'm going to draw out the triangles that I can see. So The first triangle that I've got here is the smaller one at the top, where this is 3.2 and this is 2.6. And one of the things that I'm using here is I'm actually using angle facts. So this angle here is the same as this angle here, and that's using angles on parallel lines. So we have corresponding angles on parallel lines, and these are the same as each other. And actually that is also true over here. So I've got this angle here is the same as this angle here. So I now have a larger triangle with the same angles. So looking at the sides, now this is where things become a little bit tricky. This side here is actually all of this. So I am going all the way up here. So if that side is all of this, I'm going to have to add those together. So I am going to have to add 3.2 and 4.6, which gives me 7.8. So on my larger triangle, this is actually 7.8. And then I am now going to try and work out what's going on. So I can work out the scale factor first of all. So my scale factor, this side corresponds, it matches with this side. There we are. So in order to find out what that is, I am going to do 7.8 divided by 3.2. Now that one isn't a particularly nice number. The factor here is 2.4375, and that's okay. It won't always be a nice number. So sometimes it will be, but especially on a calculator paper, don't worry too much if you don't get a particularly nice number. Now with this one, I now know that to get from here to here, I multiply by 2.4375. So I'm now going to find the length of this one over here. So I'm going to do 2.6 multiplied by 2.4375, and that gives me 6.3375 as being this length. But what I've actually found, I've found the whole of this length here as being this 6.3375, and I've actually found all of this. So I found the whole of this side of the larger triangle. Now, what they've asked me for is they've asked me for x. So in order to find just this part, I need to take my 6.3375 and I need to subtract that 2.6 from it. And when I subtract that 2.6, so this is x I'm working out. When I subtract 2.6, I find that x is 3.7375, and the units would be centimetres because I'm working in centimetres. So this is just an example of a nasty one where it's not quite so easy to see what they're actually asking you. So let's look at other polygons now. We've had a look at similar triangles. Now we're going to look at other polygons. In other polygons, they're similar if the angles are the same and the corresponding sides are in the same ratio. And in this example, it says the diagram shows two similar quadrilaterals. Calculate the length BC and calculate the length RS. So BC, they're asking me to find this one, and RS, they are asking me to find this one. Okay, now again with this, I would prefer these to be in the same orientation. So I'm going to resketch this smaller quadrilateral down here. So I'm going to resketch it just so that it looks a little bit more like the one above. I'm not doing a great job, but it only needs to be rough. And I need 1 here and 2 here. So looking at this, it means that this one must be 2. And then here the 5 is up next to where I've got the 2 parts of the angle. So that means this one must be the 5 here. So having done that, I can now see which sides correspond, and it's these ones here. So in order to find my scale factor, I do 4.4 divided by 2, which gives me a scale factor of 2.2. So to get from the smaller quadrilateral to the larger quadrilateral, I'm going to multiply by 2.2. So in order to find A, I'm just going to multiply 5 by 2.2. So my A value is 5 multiplied by 2.2, which is 11, and my units are centimetres. Then they want me to find B. Now B was RS, and that's opposite the 2. So this one's B over here. So I can now see that here the 6.6 corresponds with B. And this time I'm working on the smaller quadrilateral. So I am going to divide by 2.2 to go this way. In order to find B, I do 6.6 divided by 2.2, and that gives me B as being 3 centimetres. I've got one of those for you to try now. So here I have 2 stars, and my 2 stars are similar. So have a look at these. Can you please calculate those missing lengths A and B? And again, I'm just going to pause for maybe 30 seconds to a minute, and if you need more time, then you can pause the presentation. Okay, let's have a look at this one. So the first thing you needed to do was you needed to spot which sides corresponded. So here I've got 0.6 and 0.84. So I'm going to do 0.84 divided by 0.6, and that gives me a scale factor of 1.4. So I now know that to get from the smaller star to the larger star, I just multiply the lengths by 1.4. Then I've been given the measurement here of 0.5 on the smaller one. So to get to the larger one, I'm going to multiply by 1.4. So that gives me A is equal to 0.5 multiplied by 1.4. So my A value is 0.7 centimetres. And then for the B value, I'm going the other way. So to go from the larger to the smaller, I'm going to divide by 1.4. So I now need to do, my B value is going to be 1.4 divided by 1.4, and 1.4 divided by 1.4 is 1, so that is just 1 centimetre. Now we're going to have a look at the next part of this, and this is similar area and volume. Now the similar area and volume, it's a little bit more tricky, and it tends to come up a little bit later in the paper. And what happens is that people don't realise that the question is area and volume, because they'll just look at it like this and they'll say, oh, it's 3 times the size, and then think that was a really easy 4 marks. Now, you're not going to get a really easy 4 marks towards the end of the higher paper or in the second half of the higher paper. So it just needs to be a little clue that if you are looking at a question is towards the second half of the higher paper and you think, oh, that's a really easy one, it might be because you've missed something. And quite often it's because you've thought about similar lengths rather than similar areas and volumes. So let's have a look at these. Now with these, I've got 2 squares at the top, and you can see that the length on these, you can see the length here, it's double. And I need to find the area of each of these squares. So the smaller one, to find the area, it's 2 multiplied by 2. So this one's going to be 4 centimetres squared. And this one, to find the area, it's just 4 multiplied by 4. It is 16 centimetres squared. So although the lengths are doubled on this square, the areas aren't. And if we look at this, 16 divided by 4, this is 4 times larger. So where my length is twice as long, my area is now 4 times the size of the smaller square. Let's have a look at the same thing with volume. So here, looking at the length, so the length here is multiplied by 2. Let's see what happens when we work out the volumes. So the volume of the smaller cube, well, that's 2 multiplied by 2 multiplied by 2. So that's 8 centimetres cubed. And then here, I've got to find the volume of this one. So that's 4 multiplied by 4 multiplied by 4. So that one is 4 4s are 16, multiplied by 4 is 64 centimetres cubed. And if you do 64 divided by 8, that is 8 times the size. So where the length here is doubled, it's still got sides that are twice as long, the volume is 8 times the size. So where do these numbers come from? Well, let's have a look at this one. Here, where I've got my length double, the area here is 4 times, and the volume, where the lengths are double, the volume is 8 times. And where that actually comes from is here, click that, where my length here, it's twice as long, the area is 2 squared. So that 4, it's 4 because it's 2 squared. And then here, where my length is 2, it's twice as long, then that 8 comes from 2 cubed. And we can use that, and I'll show you how we can use that. So for similar shapes, the area scale factor is the square of the linear scale factor. For similar solids, the volume scale factor is the cube of the linear scale factor. Now, all those are, and I tend to think about them just using letters like this. If the length is k, if it's k times as long, then the area is going to be k squared, and the volume is going to be k cubed. So, for example, if I had something where one shape, the lengths were 3 times as long, so multiplied by 3, then for the area, it would be 3 squared, it would be 9 times as big. And then for the volume, I would need to do 3 cubed. So 3 cubed, 9 3s are 27. It would be 27 times the volume. And we're going to use these. So let's have a look at an example of that. So this one, we're going to start with area. And it says, example, the area of the smaller shape is 80 centimetres squared. The area of the larger shape is 500 centimetres squared. The smaller shape has a width of 6 centimetres. How wide is the larger shape? Okay, so first of all, I've got to find the corresponding values. And on this one, my corresponding values, they are the area. So what I've been given is I've been told that it's area. So the area of the smaller is 80, the area of the larger is 500. So the first thing I'm going to do is I am going to divide. If I do 500 divided by 80, I get 6.25. So I've started in exactly the same way as I did with the similar lengths. But the key here is that this is area. And because it's area, I'm thinking about the square. So area, the scale factor is k squared. So I have found that k squared is equal to 6.25 because it's the area. And then I'm going to work backwards because what I want is the length. So I want to know what my length scale factor will be. So I want k. And in order to find k, I need to take the square root of both sides. So the square root of k squared is k. And now I need to find the square root of 6.25. And the square root of 6.25 is 2.5. So if my area scale factor is 6.25 I have to square root that to find my length scale factor. And I now know that the scale factor here is going to be multiplied by 2.5. So if I call this one x, I would say, well, I'm working from the smaller to the larger. So x is going to be 6 multiplied by 2.5. So that is going to be 15 centimetres. So that's an example of using the area where I've been given the areas and I need to work backwards to find out what the length scale factor would be and then use it. And this is the one where people get confused in an exam, is they find that 6.25 and then they just do 6 multiplied by 6.25 and they forget that that wasn't a length scale factor, it was an area scale factor. Okay, so have a look at this one. It says the quadrilaterals are similar. The area of the smaller quadrilateral is 38 centimetres squared. Calculate the area of the larger quadrilateral. So can you try that one, please? And again, I'm just going to give you a very short amount of time to try that. Let's have a look at this one then. So pause the presentation if you need more time. With this one, I've been given the length this time. So again, I can work out my scale factor here. So my scale factor here, 24 divided by 6 is 4. So I now know that the length scale factor I'm multiplying by 4. And because that's length, I am going to write down k is equal to 4. But this time I'm being asked about the area. So I'm being told that the area of the smaller quadrilateral is 38 centimetres squared. So this isn't going to be 4 times larger. What I'm going to need to work out is I'm going to need to work out k squared because we are dealing with area. So k squared, that's going to be 4 squared. So I now know that my scale factor is going to be 16. So my area scale factor, it's going to be multiply by 16. And I was told that the area of the smaller quadrilateral was 38. And all I need to do is multiply my 38 by 16 and I get 608 centimetres squared. Let's have a look at the volume. So very similar. I've got an example here and it says 2 similar rugby balls are shown below. The volume of the larger ball is 405 centimetres cubed. Calculate the volume of the smaller rugby ball. And I've been given the 2 lengths. So the first thing I'm going to do is I'm going to find my scale factor. So to find my scale factor, and I'm going to think to go from the smaller to the larger, I need to do 27 divided by 18. And 27 divided by 18 is 1.5. So this ball is an enlargement with scale factor of 1.5. So I'm going to write down k is equal to 1.5 because that's my length scale factor. And then they're interested in the volume. So I now know that I need k cubed because it's k cubed for volume. So I need to do 1.5 cubed, and that is 3.375. So I now know that the volume of the larger ball is 3.375 times the volume of the smaller ball. But with this one, they have given me the volume of the larger ball. is 405 centimetres cubed. So because I've been given the larger ball, I need to divide. So I am going to do 405 divided by 3.375, and that is 120 centimetres cubed. Okay, so I've got one of those for you to try now. So here I have two similar curling stones are shown below. The volume of the smaller curling stone is 966 centimetres cubed. Calculate the volume of the larger curling stone, and you've been given two measurements on these curling stones. So I'm just going to give you about a minute to try this one, and then we'll see what the answer is. Okay, let's have a look at this one. So with this one, first thing to do is to work out the scale factor. So working out my scale factor here, I am just going to do 11 divided by 8, and 11 divided by 8 is 1.375. So I now know that my K value is 1.375, or just 11/8. We're talking about volume, so I am interested in K cubed. So I need 1.375 cubed. And when I pop that into my calculator, I'm getting, and it's 2.5996093.8. So I am working out the volume of the larger curling stone. So I am going to need to multiply. So it's 966, which is the volume of the smaller one, multiplied by, and you can either multiply it by the decimal, or you could just multiply it by 11/8 cubed like this. And the answer to that one will be 2,511.2222656 centimetres cubed. Okay, let's have a look at another one. So with this one, now this is probably the more complicated type, and what we've got here is they haven't given us any lengths at all. So instead it says the area, the diagram shows two similar ice cream cones. The area of the circular end of the larger cone is 20.58. The volume of the larger cone is 109.76 centimetres cubed. The area of the circular end of the smaller cone is 10.5 centimetres squared. Calculate the volume of the smaller cone. So we've been given area and we want volume. So with this one, let's see what we've got. So I've been given two areas. So on this one, I've got the area of this top part is 20.58. And on this one, I've got the area of the smaller one is 10.5 of the top part. So the first thing to do is to work out what my area scale factor is. So I'm going to do 20.58, and I'm going to divide that by 10.5. And when I do that, I get an answer of 1.96. And that was area. So that's K squared, because it's just an area scale factor. So K squared is equal to 1.96. Okay, so if that's K squared, what I now need to do is I now need to go back and work out what K is. So to find K, I am going to do the square root. So I'm square rooting both sides, and I need to find the root of 1.96. And the root of 1.96 is 1.4. Now that I've found my K, the question is asking me about volume. So I've been told the volume of the larger cone is 109.76 centimetres cubed. And I have to find the volume of the smaller cone. So I'm finding the volume of the smaller cone, so I know I'm expecting an answer that is going to be smaller than 109.76. So with this one, I'm going to be dividing. So it's 109.76. And I am going to, oh, one moment, look what I haven't done. So I'm looking at this and I'm thinking, oh, yeah, okay, I found K. I'm going to divide by K. I'm going to divide by 1.4, but look, that's length. So this one here, this is the length scale factor. And of course, that isn't what they want at all. They want the volume. So the first thing I've got to do is find my volume scale factor. So for my volume scale factor, I need K cubed. So I've got to do 1.4 cubed. And if I do 1.4 cubed, it's 2.744. So there's this extra step, because just going backwards and finding out what K was isn't sufficient. I am going to need to go and find K cubed because they want the volume. So this is the more complicated type where they've started with area, and from there I've had to move backwards to find the area scale factor, and from that the length scale factor. Now I've had to find the volume scale factor, and now I can answer the question. So the volume of the larger cone was 109.76. So I now need to divide that by the volume scale factor, which is 2.744. And if I divide this by my volume scale factor, then the answer is actually 40. And that is 40, what are we doing, volume? So that's going to be centimetres cubed will be the units on that one. Okay, so I'm just going to show you one more. So the one more that I'm going to show you is here. This is an example of a past paper question where they don't actually give you a picture. So it is also possible where you may have one of these where you aren't given a picture. And the way that you would deal with this is I would just draw something. So it says two similar shapes have areas of 700 and 140. The perimeter of the smaller shape is 83. Calculate the perimeter of the larger shape. Give your answer correct to two significant figures. So with this, I would just sketch any two shapes. So I'm just going to sketch a couple of, badly sketch a couple of squares. So this one, we're talking about an area of 140 on the smaller one and an area of 700 on the larger one. So in order to find my scale factor here, I'm doing 700 divided by 140, which is 5, but that's area. So I'm starting with K squared is equal to 5. And then they're interested in perimeter. Now, perimeter is length because we're talking about the distance around the outside. So I'm going to need my length scale factor. So to find K, I need to take the square root. So K is the square root of 5. And I'm not going to bother working that out as a decimal. I'm just going to work with root 5 because I'm going to get a more accurate answer. Quite often it's easier to work with the surds. So quite often in an exam situation, it's much easier to work with the surds or to leave the pi in until you get to the end and then just change to decimals at the end, unless it says that it wants an accurate answer, or to leave your answer in terms of pi if you're working on circles. So with this one, the perimeter of the smaller shape was 83 and we need the perimeter of the larger shape. So all I've got to do is multiply by my length scale factor, which is K. So I just have to do 83 multiplied by root 5. And if I work that one out and change it into a decimal, I get 185.59364213. And then I just do need to go back and double check that I've answered the question. And if you look here, it says give your answer correct to two significant figures. So that means there's going to be a mark for the rounding at the end. Two significant figures, two most important numbers, the 1 and the 8. So I'm going to draw a line after that and look at the 5. A 5 rounds up. So this 1/8 rounds up to being 1/9, but a number like 185.59 something, that can't round to 19. So I need to pop a note on to keep the place value. So to two significant figures, my perimeter would be 190 centimetres. Okay, so I'm just going to very quickly look at the things that you need to remember. So the things to remember from today's revision session. Firstly, in similar triangles, the angles are the same, or the sides are in the same ratio. So if you have to prove that triangles are similar, you can either prove that the angles are the same, or you can prove that the sides are in the same ratio. For similar shapes, when we're talking about length, divide two matching corresponding sides in order to find the scale factor. And then when we get on to the more complicated questions, and these tend to be in the second half of the higher tier paper, you need to remember that your length scale factor is K, but you have to square it for area. So it's K squared for area, and then you have to cube it for your volume. So your volume scale factor would be K cubed. Okay, I hope that has been useful for you today, and thank you for joining us.